So, yeah, we're going to have a bit of an open floor on microservices. I don't know if you want to break or if you want to pitch in, entirely up to you, sir. I think if it's all right with you, Andrew, we'll come back to you. Are you all right summarising what you just said again, just to kick us off? Can you summarise what you said? Kick us off.
So let's talk about this microservices thing. Why do we make microservices? We make it to get rid of the monolith. Don't do what I have seen, which is, oh, we've got this huge MuleSoft instance doing 7 things. So what we'll do is we'll turn around a microservice by having 7 huge MuleSoft instances, each doing 1 thing. This is not how to do microservices, because it's not about the service or even the number of components that the service provides or services. It's about being able to adjust the environment, the performance, the needs and requirements of each service. Some things need only simple requirements. A web server mostly doesn't need much resources, it's just serving static files. You're doing something that you're doing a lot of processing, a lot of crunching, it needs a lot more resources. You may need, in the container world, you may need to scale this to multiple instances. That's something else that having a microservices architecture allows you to do, which is to have multiple pods, sets, individual containers, whatever, scale that out horizontally, on demand, whatever, deal with the load balancing. What microservices gives you really is flexibility. Flexibility in terms of the service interactions and flexibility in terms of the service scaling, sizing, adjustment, performance tweaks, and so on. A different service running a different application may need different optimizations for disk access, net access, whatever. That's what microservices really gives you, the micro adjustability of each of the services. It's nothing to do with the size of the service. So microservices is a misnomer, a bit like big data.
Let's look at starting on big data. Sean, you're going to say something about that, yeah? Please put your hand up if you want to respond, and I'll bring your mic.
So, I'm not saying you should, but you can take a monolithic thing with different entry points, so like a jar file with different entry points that do different things and do them well, and deploy the same thing 50 times and say these 10 are this thing, and these 5 are this thing, and these 20 are this thing. And it will work, and it will work as efficiently as if you compiled them down into different jar files and excluded some of the code base. Obviously, it's not ideal for your attack surface, but technically and functionally, there's very little difference. It will still work. You could take your 7 things, your 7 multifunctional things, and say, well, this is this flavour of it, this is this flavour of it, and then scale those individually, because we're not so worried about footprint anymore. You know, we're not worried about a jar file being 50 meg instead of 20 meg. So it's the same pattern, it's still a microservices pattern. I'm not saying it's ideal, but it's doable and it will work.
Sorry, I'll pass the mic down.
What about when you have to test what you're going to deploy? If you do that, if you just want the little things in one service, if you deploy that monolith to that one service, your suspect code is basically all of your monolith before you deploy it, because you change that piece of code. If you have a traditional microservice where they're separate, then you haven't touched the code in the microservices.
Yeah,
so I think that's the difference.
It does change. So your original functional test said this bit works. Your unit tests haven't really changed. But your functional tests say, yeah, this thing works as a whole. So yes, one of the layers of your test pyramid is different. The others are essentially the same.
I think the thing that you're sort of essentially hitting on is that most of the reason I think microservices exist is more about breaking down the projects to match team sizes. That's something that people often forget, because you have a massive monolith and you have more than 3 or 4 teams contributing to it. All of those changes in flight are very hard to synchronize, and when you decide to go down that microservices route and split them up based on more feature level, based on the team that works on it, you actually get a lot of benefits that people forget about.
Yeah, is there a corollary there with continuous delivery, perhaps, where you're releasing things when they're ready? And yeah, if you've got the right size team deploying the right size piece of software, you can just shut it out straight away, right? Could be better, huh? Phil, you say something?
I think one of the things you've got to remember as well is we all have a limit in our own brains as to what we can keep. And when you're working on a monolith, it's so easy for you to stray out of your area and impact something which is just totally disconnected to where you were. And I think Nick summed it up brilliantly with what's the size is the size of the head. What can we hold in our head? That often comes down to what we can sensibly work on. And even in a team, you're actually going, what can we hold in 2 heads, 3 heads? But once you get beyond that, people stop talking to each other. They don't share that knowledge, they don't interact. You don't know what the rest of the team know. And so you need to make sure, in my mind, that microservices are capable of being understood by the people who are working on that, which may be that some people only work on very small units, whereas other people can work with something a bit bigger. But what you don't try and do is give somebody a monolithic solution and expect them not to impact areas outside their knowledge.
Thank you, Phil. Anyone want to respond to that? Yeah, can you pass the mic down, please?
The fine gentleman on my left has mentioned that the teams is quite important because microservices allow to spread the actual work across teams. However, another advantage of spreading the work around different teams and splitting the monolith into microservices is actually you can change the technology. You can have the monolith in Java, then you split it in smaller bits into microservices, still in Java, but then one of the teams decides, all right, we need to optimize it, go for Golang. Another team decides to go for Node.js. You can actually choose different technologies for different microservices. And as long as you keep the API and interface the same, it doesn't matter.
Because it's on its way there. So the next thing I was going to say was that the other example is that microservices plus mono repos equals Nick's magic word of reuse.
Yeah, the idea of splitting them up is also interesting in terms of network, that people really forget networks are horribly unreliable. So that's definitely an extra bit there, and I think there's a misnomer around the scaling aspect. Yes, you can do it, and yes, you can change the technology underneath, but most languages now, most people are not hitting the scaling problems at that point. It's usually around that we want this particular section of functionality to be at a higher scale, rather than necessarily it needing to be a different language.
Yeah, maybe. No response to that.
Yeah, come to you, you can then go to Andrew.
So I will pass it on, Andrew. The trouble is, when you hit that gold line, then you're screwed. If you do things like that, if you ignore, so Paul Graham was saying last month or the month before, he was saying, if you're working in a startup, build as much technical debt as you can cope with. She's right, isn't it? That's right. That's the right thing. The startups often fail because people are over-engineering. They're trying to do things too nicely. You want to fly as much by the seat of your pants. You want as much financial debt and as much technical debt as you can cope with. The trouble is, then you've got to deal with it. Now, if you could make it easy to build things that were scalable, if you weren't having to make that deal with the devil, that I can either do this shit fast or well and slow, but if you could make it good enough fast or scalable fast, then why wouldn't you do that? That's what I'm trying to say. That's the benefit. So I'd also like to pick an argument with what you're saying. Not just about that, but I understand what you're saying. They are about that. And many of the things that everybody else has said, they're about the fungibility, about being able to do stuff to them. But they're also about the developer being able to fit in their head to answer a problem that is clear. And somebody else comes along, it's that old joke about make code as if the next person who's going to work on your stuff is a psychopath who knows where you live. And microservices feel like a way to avoid him coming around your house and killing you.
So, following up on your remark, it's Jeff Bezos' famous 5-line memo, isn't it, about APIs? Every service will communicate via an API, no back channels, no reading with databases, no shared memory, nothing. Every API must be externalizable. You're happy to put it out to the ultimate internet, and anyone who doesn't do this will be fired, right? That's the API thing. The other thing with microservices is there's a tender trap in here. Who here has heard of an author called Charles Perrow? Not Ross Perrow, Perrow as in P-E-R-R-O-W. Charles Perrow wrote a very important book called Normal Accidents. It was based on the 3 Mile Island nuclear incident, where one initial alert produced a whole series of cascades that completely obscured the real problem to the operators who were trying to deal with all this shit and alarms. Now, what he was discussing in that book is the principle of tight coupling. The tighter you couple systems together, the greater the range and the damage of side effects, or cock-ups, or bugs. So loosely coupled is what you want. Now, monoliths are by definition tightly coupled. It's all in the monolith. The mistake is to turn the microservices into a tightly coupled set of microservices. All you've done is move the coupling problem from inside the monolith to outside it. So the point you made about networks being unreliable and all that kind of thing is absolutely right. And this is where Chaos Monkey and Istio, service meshes and deliberate failures and timeouts and fault introduction are so important. Everything has to be made fault tolerant by design. Then you can rush off into the attractive Wild West of microservices, confident that it will survive problems like that. Otherwise, you just move the problem from inside the monolith to outside.
Well, thanks, Andrew. Okay, let's go to you, sir. So, what's your name?
First of all, I'm very hard to scare, so after what I will tell, I don't bother. I actually think that people are severely misusing microservices. Multiple times I came across, like you say, companies who are actually praying for scaling problems. They build, by design, they build beautiful microservices, they have huge overhead on load balancing, service discovery, secret distribution, PKI infrastructure, all of that surrounding, and then their difference between like the lowest and the highest peak is 3%. Another thing is that, okay, you can introduce, like you said, many technologies, you can shift between technologies. What about attack surface? If you actually have one technology, which is most probably 20,000 or 20 million line codes of Java, you actually can have a team which doesn't sleep, doesn't eat, they only look at the security backlogs in other companies, look like, oh, we hit this, we have this, and we will patch it. They know that. If you have a microservice, let's do Node.js, let's do Golang, let's do that. And suddenly, sometimes it's even hard to replace people because you have 3 people who know Golang, one goes on maternity leave, one leaves, and the third one is hit by a bus, and you're effectively back. And the last thing is about cooperation between teams. Decoupling is awesome, but has anyone actually tried to change an interface of microservices when you already have 7,000 of them, and the impact is on 60% of those teams? How does that really differ from changing a thing in monolith? And for example, why don't we use libraries? Why can we actually sort of tune stuff to a certain OS, to a certain VM nowadays, with a certain amount of processes that you actually can run, and literally squeeze out everything what you can from those machines?
Lots of good points, and I think there are some good answers for quite a lot of those things, which I will take over a bit later. We're a bit short of time. Thank you, everyone. Does anybody who's not spoken so far want to add anything to the discussion? Any big monolith lovers in the room, perhaps? Okay, cool. We covered a lot of stuff, lots of interesting opinions. So people are broadly in favour of this way of doing stuff, evidently. Not without its challenges, as we said. But yeah, there's answers to a lot of this stuff. It would seem. So yes, so thank you very much for everyone for contributing to that discussion. What we'll do now is we'll take a very, very quick break because there is a bit more beer left. Right? Just get a beer. If you can literally just get a beer and then come straight back and then we'll get the last talk on. So we need to be out there by 8:45. So thank you.